Okay, so if we look at this same problem from the perspective of finding the extrema by finding critical numbers, taking the first derivative and set it equal to 0, we can do that too. What's it look like? Well, f prime of x, 2 is a constant multiple, so it just goes along for the ride, right? And the derivative of secant is secant tangent. And then we have the copy step, and then dx. So we're done with this. So we would need to see where is this thing equal to 0. We can divide both sides by 2. And we end up with this, right? Secant's 1 over cosine. We already said that this thing is never equal to 0, right? And then here we have tangent, and this is sine over cosine. So this product is going to be 0. Since this is never 0, this product is going to be 0 when this is 0. And when this is 0, and this is going to be 0 when sine x equals 0. Because when cosine x is 0, this thing wouldn't exist. Cosine of 0 is 1. Cosine 0, sine 0 is 0. So 0 actually works here. So we have, this boils down to sine x equals 0, and we know that that means x equals 0. That's in our domain. So we're kind of done, but we don't know whether this is a maximum or a minimum, okay? So how would we find that out? Well, one way would be to take the second derivative of this thing and find out if it's concave up or concave down. So the second derivative of this function, here's our first derivative. So for the second derivative, the constant multiple still just goes along for the ride. But here we have a product rule, right? So we're going to end up with product rule. And the first thing goes in here. The second thing goes in here. Right? The derivative of secant is, as we just did, secant tangent. And the derivative of tangent is secant squared. So we want to know, is this thing positive or is it negative when x equals 0? Okay? If it's positive, then we have that it's concave up, yeah? And if it's negative, we have that it's concave down. So let's plug in 0, right? So we get 2, secant 0, this is actually cubed, right? Plus, okay, tangent 0 is 0. All right, so that makes this term 0. And so what's secant of 0 cubed? Well, remember, secant's 1 over cosine, so this is 1 over cosine 0. Cosine 0 is 1, so this is 1 cubed, so this is 1, this value here. 2 times 1 is 2. So this is positive, right? So we have this situation right here, right? And we know that our critical point, if we have a critical point in an area of positive concavity, it must be a minimum right there, right? So we know that it's a minimum by using the second derivative. Seems kind of like overkill when this is so easy to graph, but there you have it using critical numbers.